the beating heart of a modern nation. Billions of pounds of steel every year, millions of pounds of glass and aluminum, of rubber and plastic, of copper and lead and zinc alloys, millions of yards of fabrics, all being cut and stamped and sewn, components being readied for assembly, all destined to serve the transportation needs of a modern society that has grown and prospered in large part because of the automobile and what it has allowed people to do. From 20 different fabricating plants they come, from thousands of supplier companies, components of all sizes and shapes, arriving in 26 assembly plants here and in Canada, each part to be assembled together with the next, quickly, efficiently, until finally there emerges the engineering and manufacturing miracle that is a modern automobile body. One new body every 3 seconds, 1,200 every working hour by one company alone. How does it happen? Year after year, this ever-continuing cycle of new high-quality automobile bodies for General Motors cars? The answer can be found by looking to the bodybuilders from Fisher. An automobile body is the part from the engine compartment to the rear end. It is the passenger compartment, the part people see and touch and ride in. And it must be designed with people in mind. In a world of rapidly changing technology, there are many opportunities for talented men to create new design concepts for comfort and safety. Seeking new ideas is really where the bodybuilders from Fisher begin their cycle. While this year's automobiles are being manufactured on the assembly line, people in the advanced engineering department are working far into the future, exploring new avenues of design, new ways of doing a job, new concepts that increase safety. Innovation is the key word of this group of bodybuilders. Experimentation with various types of restraint systems, perhaps. Always seeking to find the best way to assure freedom from injury for every passenger in the car, even the youngest tot. Studies into the anatomy of the human body itself to find where restraints inside the car can and should be placed. A new design that will simplify construction of an important part of the car body and at the same time make it stronger. Experimentation with new materials, new manufacturing concepts, new computer techniques for analyzing test results. The annual model change permits improvements to be incorporated in new cars as quickly as they are tested and proved. But a constant challenge is cost. How can a better quality, safer automobile body be built without increasing its cost to its customer, especially in the face of rising costs of materials and labor? Working to meet this challenge requires a high degree of engineering creativity. It is an environment where every man is encouraged to submit ideas, and every idea is considered. While the advanced engineers at Fisher are exploring new concepts, the stylists are putting their ideas on paper. They develop a basic styling package for each General Motors car, a creative concept that evolves after countless discussions with the bodybuilders from Fisher, representatives of the GM car divisions, and top General Motors management. This sharing of ideas begins nearly 3 years ahead of a scheduled new model introduction. It is a creative give and take that has but one goal: to come up with the finest, safest, most attractive automobiles it is possible to build. During these early discussions, the bodybuilder presents what he calls a shopping list of new manufacturing concepts and innovations that may make new styling effects possible. From exchanges like these have come such innovations as hard top styling, side impact construction, integrated body and fender design, windshield defrosting, acrylic lacquer, push-button door releases, cushioned instrument panels, keyless locking, and many others. A major emphasis is on what is called human accommodation, the comfort factor, ease of entry and egress, the contour and construction of seats, head height dimensions, shoulder room, hip room, leg room. They all must be resolved by the stylist before a design concept can be settled on. After countless discussions, presentations, and meetings, a styling concept is finally approved. The new car, destined for introduction some 30 months later, is carefully modeled in clay. Each dimension of the clay model is accurate to a fraction of an inch. The problem is getting the dimensions from the clay model into a form the bodybuilders can use to design the structural details of the car and the tools and dies needed to build it in great quantities. At General Motors, a complex electronic system is used to acquire the data from the clay. The system begins with an electronic surface recorder that acquires contour dimensions of large body areas and transfers them to engineering drawings. This replaces the laborious hand methods that were previously used. A three-dimensional photographic technique called photogrammetry is used to determine the basic dimensions of complex surface details, such as moldings and glass openings. Mylar drawings are made to these dimensions, and the basic shape of the clay model is transferred to paper. Next step, the information on the drawings is transformed into language a computer can understand. This process, called digitizing, puts the basic dimensions of the clay on punched tape. The data on the paper tape is transferred to magnetic tape, then to storage discs, and a refining process begins. By now, the group of Fisher bodybuilders called product engineers are hard at work. Sweetening, they call this process of smoothing out the body surface dimensions to the precise degree necessary for the design of structural components, tools, and dies. By the time all the final contours of the body have been determined, a central computer contains a master mathematical model of the body's shape with precise dimensions. Since all Fisher body engineering activities are connected to the computer, this stored information is readily available to anyone who needs it. Tapes containing body dimensional data can be used to control machines that do a number of important jobs. Detailed master drawings can automatically be made of any component, to any scale, in any type of presentation the engineer desires, even perspective views. Cutting tools can automatically shape wood models that duplicate segments of the body surface, an important step in the development of tools and dies. Complex milling machines can automatically shape metal parts for test bodies. Patterns can be cut automatically. Computers allow machines to do tedious, repetitive tasks. They free the stylist and engineer for better use of their creative talents. They relieve the draftsman of many hours of laborious basic tasks, permitting him to concentrate on the design of the thousands of structural parts necessary to construct the final body. They give the skilled model maker a head start, leaving the fine detail work to the irreplaceable human touch. They help the die maker by enabling basic die design work to be done quickly and efficiently. Dies are used to stamp out the metal parts of the body. They are designed with the help of a computer system called Inca, a development of the General Motors Manufacturing Development Organization. Parts programmers tell the computer the surface area desired, and a tape is produced that can control the machines that shape the dies. The Fisher bodybuilders have used these machines to make the temporary soft metal dies that form parts for test bodies. Similar tape-controlled machines may one day make the final hard metal dies used for high-volume production parts. Hand-built test bodies play an important part in the development of a General Motors car. These bodies are subjected to a rugged evaluation program in some of the most elaborate laboratory test facilities in the world. Only in this way can the bodybuilders be sure that every part fits together the way it has been designed to fit and does the job it was designed to do. Quality of the final product is the purpose of all this laboratory testing. Will a new roof design withstand forces likely to be encountered in a rollover? Will the body stand up to Arctic-type cold or Sahara-type heat? Will a door open and close the specified number of times without fault? Will a new seat fabric withstand the prescribed amount of wear? Do the moving parts operate without objectionable noise? Will a new model design accept a proposed production line paint dipping technique? Many questions can be answered only on the road, and the extraordinary facilities of the General Motors Proving Ground are kept busy by the bodybuilders. It is still months before the new model is scheduled for mass production. Time for changes that will improve the quality of the final body. Hand-built prototype models undergo carefully programmed durability runs that compress thousands of miles of average driving into a few weeks. These prototypes are bruised, beaten, battered, even destroyed. Studies of all tests help the bodybuilders correct any flaws in design or construction. They can study the effects of impact on passengers. They can see the effect of additional protective structural elements built into the body. They can determine if their design meets the high durability and safety standards set for all bodies by Fisher. While testing goes on, process engineers have been completing the design of the tools and dies necessary to mass produce the body. Pilot lines have been built at Fisher Body Engineering so tooling could be checked out before it was installed in the plants. Finally, the bodybuilders decide everything is ready. It has been 2 years since this body development program began. The complex manufacturing schedule has been fed into the computers. Data begins to arrive at Fisher Body plants. Production begins. In automobile body fabricating plants, the miracle of automobile production can clearly be seen. Raw materials of every type are purchased from many thousands of suppliers throughout the country. They are transformed into precisely designed components that later on will be assembled together to form the finished automobile body. There are about 4,200 parts in a typical Fisher Body model, 4,200 parts per model, and as many as 160 different models may be built in a single year for the 5 car divisions of General Motors: Chevrolet, Pontiac, Oldsmobile, Buick, and Cadillac. That means hundreds of thousands of different parts must be built each year, and every part must end up at the right place at the right time. Attention to quality is the major charge of the bodybuilders. Attention to every detail in Fisher Body's 11 metal fabricating plants. and in the 4 trim fabrication plants. No part of an automobile is scrutinized more carefully by the owner than its interior trim. At Fisher Body, special care is taken to assure that the tiniest detail is free from defects. The personal touch is very much in evidence in the trim fabricating plants. Experienced seamstresses stitch seat coverings and door trim and headliners. Machinery helps where it can, as in the fabrication of foam-filled door panels. But always the human touch is present. Women who know what they like in their own automobiles work to make every interior appointment as close to perfection as possible. Full automation has come to one section of the trim fabricating plants. Tape-controlled stitchers do delicate embroidery in minutes, flawlessly. The same job done by hand would take many, many hours. Quality is also the byword in Fisher's 5 hardware plants. Here, an almost infinite variety of components are fabricated, parts that are important both to function and appearance of the automobile body. They range in size from this intricate die-cast grille to this tiny jewel-like crest. They include window regulators, manual and electric, push-button door handles, door hinges, locks, moldings, and many other items. The hardware plant is a busy place where the teamwork between people and machines is especially evident. In each of the fabricating plants, a continuous test program checks on the quality of the manufactured parts. Do the chrome parts withstand corrosion? Will a sample of vinyl trim withstand the severe stresses of vacuum forming? Does a metal component meet the precise dimensional requirements? Sample production parts are cycled, cut, pulled, flexed, rubbed, baked, frozen, weathered, measured, remeasured. If anything fails to meet specifications, corrective action is taken immediately. Only acceptable components are approved for assembly. There are many plants where Fisher bodies are assembled, but in each one there is a common endeavor. Reduce the amount of decision-making required. Provide tooling that simplifies the job. Give the bodybuilders on the assembly line all the help you can. Short framing is one way this is done. Provide automatic side frame fixtures just long enough to let the body sides be tack welded in place. Then remove the frames and let automatic welding devices do the welding job. One such device is SAM, the 6-axis manipulator that duplicates the action of the human arm and wrist and permits automatic welding of places heretofore inaccessible to welding machines. Other automatic equipment assures sound, precision welds. the body structure begins to take shape. The pace of the assembly line is steady. Weld inspection. Weld smooth up. Weld finishing. Deck lid assembly. Door installation. Buyout inspection. Here's where the results of the long months of body surface development show up. The contours flow smoothly. The body that began as stylist clay has emerged in hard steel. The assembly line continues without pause, up to the second deck and on to begin the important painting process. Bonderizing first, 6 stages that prepare the metal surfaces for paint. Clean, rinse, rinse, rust-proof, rinse, rinse. Then priming, a corrosion-resistant primer inside and out. Then baking, followed by wet sanding and primer sealing. Finally, painting. Long-lasting acrylic lacquer, sprayed on by a technique that never varies the coating more than 1/2 thousandths of an inch from the specified thickness. More than 23 million gallons of paint are used in a single year. The bodies continue without interruption. The conveyor course is laid out so that flaws or defects can be corrected without taking a body off the line. For everything is programmed in sequence, and somewhere in another part of the assembly plant, seats and interior trim of just the right color are heading for a rendezvous with a particular body. The right color soft trim is there, and the final finishing of the body takes place. Then, the most dramatic of all the assembly line inspections, the water tunnel. Here, the body is drenched while inspectors check every nook and cranny for leaks. More trim installation, headliner, door pads, armrests, and then still another inspection, again with extra lengths of conveyor that permit touch-ups to be made without losing sequence. Finally, the right color seat moves into place and assembly is completed. Final inspection. Body okay. Trim okay. Release to the car division. The bodybuilder's job is done. The line continues, in some cases, right into an adjoining car division assembly plant. In others, to loading areas for shipment to distant plants. There, the gleaming Fisher body is moved into position above a line where the chassis of the automobile has been assembled. Frame, wheels, engine, transmission, brakes, steering, they all await the union with the body by Fisher. And so another General Motors car moves on its way to completion. A beautiful object indeed. In a very short while, it will be providing good, safe, dependable service for a proud and discerning buyer. And while it does, the bodybuilding cycle goes on back at Fisher Body. New ideas are being discussed. New features are being designed and built and tested. New manufacturing techniques are being considered. All this with the goal of providing better and safer automobiles in the years ahead. This is the continuing legacy of the bodybuilders, the people of Fisher Body.